Let us look at cube roots of unity. An interesting cubic equation is x cube equal to 1. Its solutions are 1 minus 1 plus I root 3 by 2 and minus 1 minus I root 3 by 2. Now, how did we arrive at this? This equation can be written as x cube minus 1 equal to 0. By the fundamental theorem of algebra, it has exactly 3 roots. One is pretty straightforward, 1. Let us solve the cubic equation. The equation can be written as x cube minus 1 cube is equal to 0. And we know a cube minus b cube can be factored. So x cube minus 1 cube equal to x minus 1 times x square plus x plus 1 equal to 0. So what does that mean? X minus 1 is equal to 0 and x square plus x plus 1 equal to 0. So the first is a linear equation where x equal to 1. Now solving the second factored equation, we get x equal to minus 1 plus or minus square root of 1 square minus 4 times 1 times 1 divided by 2 times 4. So x is equal to minus 1 plus or minus square root of minus 3 by 2. Therefore, the three solutions of the cubic equation are 1 minus 1 plus I root 3 by 2 and minus 1 minus I root 3 by 2. Now, since the solutions satisfy x cube equal to 1, they are called cube roots of unity. Now, let's look at their powers. Powers of roots of unity. Looking at the square of the second root, minus 1 plus I root 3 by 2 the whole square. Simplifying it, we get minus 1 minus I square root of 3 by 2, which is the third root. So squaring the second root gives us the third root. Now let's see what happens when we square the third root. Squaring it, we get the second root. Now let's look at the cube. So cubing the second root gives us 1 and cubing the third root again gives us 1. Now the two non-real complex conjugate roots of the unity are denoted by omega and omega square. So omega is equal to minus 1 plus I root 3 by 2 and omega square is equal to minus 1 minus I root 3 by 2. Now let's look at other powers. Omega cube, which we have already derived, and we got 1. So omega cube is equal to 1. Omega to the power of 4 can be written as omega cube times omega. Omega cube is 1. So omega to the power of 4 is omega. Omega to the power of 5 is equal to omega cube times omega square, which is equal to omega square. Because omega cube is 1. Omega to the power of 6 is 1. Omega to the power of 7 is omega. Omega to the power of 8 is omega square. Omega to the power of 9 is 1. So, if we look at these powers, the values associated with them starts repeating. 1, omega, omega square, omega cube is 1, omega to the power of 4 is omega, omega to the power of 5 is omega square. So, 1 omega, omega square starts repeating. So, which means in general, we can write it as omega to the power of 3 times k is equal to 1, omega to the power of 3k plus 1 is equal to omega, and omega to the power of 3k plus 2 is equal to omega square, where k is in the set of integers greater than or equal to 0. Now, let's very briefly look at the graph. So here x represents the real part and The y-axis represents the imaginary part. We draw a unit circle. So our first root is 1. Second root is omega. Now, how did we know to plot here? Because remember, x is the real part, y is the imaginary part. So here the real part is minus 1 by 2. So minus 1 by 2. And the imaginary part is root 3 by 2, which comes to somewhere here. Similarly, minus 1 by 2 minus root 3 by 2. So you can look at this going anti-clockwise. Omega times omega is omega square. Omega cube is 1. Omega to the power of 4 is omega. Omega to the power of 5 is omega square, and so on. So that was powers of roots of unit. And in general, we looked at cube roots of unity. That's it for now.